This video, we're going to be talking about tags. Now, before we talk about tags, we have to understand what a tag actually represents. So on our PLC here, if you notice, we have two banks. We have a digital input A bank and a digital input B bank. And then we have a digital output A, represented by the DQ. And then we have a digital output B, represented by the B here. So we have two different banks here. Now, by default, Siemens, the address would be this bank. All right. And by default, the bank starts at 0 on the semantic S7-1200. So DIA would be our address of 0, DIB would be our address of 1, same thing with our outputs. If you had more cards plugged into the side here, more input or output cards, then we could continue the addresses. So it would be maybe address 2, 3, 4, or you can make it 5, 8, 5, 6, 8. Really depends on what you're trying to do and how you want to address them. But by default, it seems to start with 0 and 1, and I assume the next card would be 2, and the next card would be 3 after that. And remember, inputs would be consecutive and outputs would be consecutive by default. Now, the I, that would be our operand. So that tells us that this would be, in fact, an input and not an output. And a Q would be our output or operand for our outputs. We also have the operand of M for memory. So that is stored inside the PLC in the RAM or ROM or non-volatile memory, one of those somewhere in there. So now in PLC Fiddle, in Siemens TI Portal, on the left-hand side, once you already added your PLC, you're going to go expand the PLC tree. So in this case, PLC 1. And normally you are starting at, wrong button. You are normally starting at this screen here once you've added your PLC. So you're going to expand the PLC tags section, and you'll notice that we have three options by default. You have the show all tags, which in this case, we're not showing any. We have the add new tag table, and we have our default tag table. Now, I personally like to group my tags by type. So traditionally, I would make a new tag table. Come on, new tag table. I'd actually make 3 of them. And one of them would be my inputs. So just if you click and then click again, it pops up that rename, just like Windows works. You can also right click and then say rename or F2. I like having an outputs one, and then I like to have a memory one, just to keep my tags all grouped together. Makes my life a little bit easier. So if we go into my inputs one, double click on that, we got our blank tag table. All right. So first thing we should do is we should give it a name. So in this case, I'm going to call it start button. And if you want to be really fancy, you can add, NO. So for normally open, not the word no, but NO. And we go ahead and hit tab. Now, by default, it automatically fills in the Boolean tag type here. And for our purposes right now, that is all we're going to be using. We're not going to be using any of the other options. That will be either later this semester or in your next class that we'll start diving into different data types. Now, the address, that is important. So if we actually click the little drop-down arrow there, you can see we have our operand identifier of I right now. If we click that, we have Q and M. Remember, I is for inputs, Q is for outputs, M is for memory. We have our address type. So remember whether we're using A or B on the built-in inputs and outputs on the PLC. And then we have the bit number. And the bit number is which number, which light, or if we open this tab up, which screw terminal up here. Let's make sure you guys can actually see that. There we go. Which screw terminal up here we are using. And again, you can see that they're all labeled right there for your pleasure. So just to make your lives a little bit easier. So address is the bank, A or B, or 0 or 1 by default. And the terminal, or the bit, is the terminal, or the light, or the screw terminal, however you want to look at it. So for this case, we also, by default, the trainers have these 8 switches on them. And it starts with 0, 0, goes to 0, 7, and then we don't have anything on 1, 0 to 1, 5. So if I want to use this switch right here for my start, it would be 0, 1, 2, 3. So I will go ahead and make this address 0, bit number 3. And I can go ahead and OK. And then I can repeat. So let me go ahead and do a stop button. I'm going to call that normally closed. That is Boolean. And you'll notice when I hit tab, it automatically fills in the next available address. So it's assuming we want to go to 4 next, which is not a bad assumption. All right, however, let's go ahead and make this 0, 0. for address 0, so block A, terminal 0. All right, and we can go ahead and hit OK. Now, something I do like to point out to make tags quickly, especially if you have multiple of the same tag type in a row, just like in Excel, there's that little square box in the bottom right-hand corner. You can click and drag on that and pull down, and it will make multiples of that exact one. And you will notice we went 0, 0, 1, 2, and then we jumped to 4. Why didn't we use 3? Well, we already used 3 for the start button, so that's why we didn't have a 0, 3 there. Now let's go ahead to our outputs. And we're just going to call this system light. And I'm going to add yellow to it because sometimes you'll have multiple system lights. And you'll notice, again, it automatically fills in the data type, which is good. However, the address this time is set for an input. So for our purposes, let's go ahead and make that a Q instead. And let's just go back to the beginning of 0, 0. And again, you can drag these down just like you could the inputs. So if you want to just have a whole bunch of system active or system light yellows, you could just drag that down like crazy and boom, now I have 7 of them. You'll notice if I do drag this even farther, it does roll instantly. So it knows 0, 7 is the highest, so then it goes to 1.0 and 1.1. And right now, according to this, we're going to 1.5. If you look closely at the PLC itself, let me get that back into frame for you, you will notice that if we look right there, bank B or address 1 only goes to a terminal of 1. We don't actually have 2, 3, 4, 5, 6, or 7. So the last few will not actually output anything in the actual program. And you can do the same thing with your memory. So let's go to the memory tag table, and I'm going to call this, I don't know, enable. And instead of address I0.5, I'm going to make this M. And I'm not going to start with address 0. 0 and 1 are normally used for your system clocks and your system, clock and your main enable byte. So I don't like to use those. So I tend to start at 3, give myself a little buffer. Now, keeping track of what memory addresses you use actually becomes very important as your programs get more and complex and you start adding more and more and more of them. If you do create another memory bit of the same data type, so same Boolean, so I could call this hello, and if I make that M0.0, you'll notice that, M3.0, not 0.0. You'll notice that they both go yellow there, and that is to warn you that, hey, this tag is already, or this address is already being used by another tag. So unless you purposely name something the exact same thing, or the exact name terminal and address, this is saying, hey, you screwed up, you need to fix this. All right. So then you might just come back to it and go, okay, make that 3.1 and you're good to go. So overall, that is tags on the PLC. These replaced you having to type out M3.1 and I0.1 every time in your PLC code. And this is saving us so much hassle when you're programming. It's so much nicer to have the tags than having to remember which terminal what is on. I remember back when I was in college doing this, that I had a list of what my inputs and my outputs were, so when I was making my program, I could reference that list instead of having to remember them all. So basically the same idea, except for I always had to check my list if I wasn't quite sure what was going on in my program. And you can imagine writing a program that you don't look at very often, forgetting very easily which tag goes to which address bit. So that is how you make tags for Alan Bradley's Siemens, not Alan Bradley, and Siemens TIA Portal V13.